Hello, welcome once again. This is a pictorial, the basic layout for a vehicle, and I think it's very appropriate. As you can see over here, we start with the battery as always. We go through an ignition switch, which goes back to the starter relay, which allows the starter motor, the solenoids, to activate to the starter motor. This is the basic diagram in pictorial ways. So as you can see over here, critical components over here, if this doesn't start, obviously corrosion on the battery or the terminals, no connection, obviously the ignition switch, obviously these wires that run from ignition switch to the starter relay, or if the relay doesn't work, and obviously you can see this wire over here that goes back to the starter motor, to the relay, to the solenoids, is critical. Basic diagram. Now, after that happens, what do you think happens? We need spark, we need fuel, we need compression, air. Battery again. Goes to the ignition switch over here. In the start position, ignition coil. This gives the spark. Now, what you don't see over here is the computer board, because this is an older version. But I think the concept is still the same, obviously. So, you have an ignition coil that starts a spark, and it goes to something called a distributor, which distributes appropriate spark in each cylinder as it revolves. So basically, troubleshooting this, as you can see, where would you go? Go to the ignition coil. Look, see if you have a spark over here. See if you have a spark going to this. You have no spark over here, forget about this. You go back and say, where did I lose it? Okay, so maybe the ignition switch doesn't work. Depends. In the start position, you work your way back. Now, after that happens, what do you think we need? We need to replenish the battery. Along comes the alternator. Alternator comes. This is an integral regulator, which is a regulator which controls the voltage output to make sure it stays constant under all load conditions. Meaning, if you put the lights on, you put the wipers on, you put the radio on, you put all accessories on, the voltage is staying the same, 14 volts, whatever it is. We have to recharge him. That's his purpose in life. It's an AC generator with diodes inside. If you have a shorted diode, you're going to have problems, obviously. So anyway, after that happens, crank the engine, pulleys start turning, serpentine belt turns the pulleys, alternator produces the voltage to back. Now we come to the accessories part of it. Your horns, your lights. The lights work with a light switch. Obviously, turning on the headlamps, the parking, the headlamps, and then we have the horn. It goes also through a fuse link, which we went over before. Then you go through the fuse panel. Then you go through the horn relay over here. Then you go through the horn, pressing it, and then the horns are activated. So basically, these are the accessories part of it. This is the mandatory part of it that you need to. Number one has to start. Number two has to start. Number three has to start to replenish him. So basically, as I said before, the BCM, the body control module, controls the headlamps today, which is obviously not seen here. Like I said, this is an older version. The horn relays, also, you have fuses, you have also a module that controls it. Starter motor, the PCM controls the starter relay. The BCM, the body control module, controls accessory. The PCM, or the ECM, known as the powertrain control module, controls this. Powertrain control module, abbreviated PCM or ECM or ECU, controls the ignition coil also, the timing of it, when it goes on and off. And the alternator also, with the PCM again, the computer controls the output of this alternator to go to the accessory, to go to this. Like I said, computer modules were, this is over 25 years ago. So basically this was the basic diagram, but everything is computerized today. But anyway, I think the concept still stays the same. There's no need to change, obviously. We still got to get the starter motor to the flywheel to the crankshaft. We still got to get spark to the engine. We still got to get fuel to the engine. We still got to get compression from the engine. We still need an alternator. We still need lights to see. We still need horns over here to use, right? So I think this is a good pictorial. But please go to my channel, Joe Electronic Schematics Auto. Please look at the videos how to load test a battery. You will be throwing batteries out for no reason if you don't load test a battery. I can't express it so so emotionally, I guess, but how much does a load tester cost? $30-$40? How much does a battery replacement cost? It'll load test the battery and it'll give you an indication if the battery is good or not good. If it is good, go on to something else, to the relay, to the starter, maybe the flywheel. So anyway, go to my other video also about how to test the alternator, the output of the alternator. How do you test it? Since I said it is computerized, trying to find a simplified way to the viewers to show how to test it. And that was when I put a clamp meter. It's not enough to me just to look at the voltage output. The voltage output of this or the battery is visible on your instrument panel, your instrument cluster on your dashboard. You have a gauge inside. It tells you the voltage. Try to pay attention to that. Why? When you first put your key in the run position, accessories go on, the lights go on, even the fuel pump turns on to get fuel pressure. That battery voltage should be 12 volts. It should not go down. If it goes down to 10.6 just in a run position, you're in trouble already. Don't think of cranking. It's not going to happen. So always pay attention to that. Okay? The lights going on when you crank, if they go dimmer, many times, guess what? You can have a good battery, you can crank, and the lights will dim, and you'll still have a good battery. So to me, it's not the best indication of the lights going dimmer or not on and off. But anyway, what I want to getting back to the subject over here. How do I test the regulator with computerized? How do I test it? That's why I put the clamp meter. The voltage should say 14 volts. We know that. What about the current? I just put on the blower motor, right? I just put on the air conditioner. I want to see at high speed. I want to see if I get current. The voltage is 14 volts. There's a voltage meter in your instrument panel, like I said before. Use that to your advantage. You don't need a multimeter, an expensive multimeter. You have the gauge in your car. So when you crank first, what's it going to be? 12 volts. When this gives spark, crankshaft turns, spark, fuel. What's going to go next? This. How much should I see on my gauge in the instrument panel? How much should I see? If you said 12 volts, you're wrong. You should see about 13.5 or something to 14 volts. Now with smart charging systems, you could see probably 16 volts. It could be normal. But for the average vehicle, let's say 14 volts. Correct? I put on the motor. I put on the blower motor, which is the fan motor on high speed. Right? I'm going to look at that gauge in that dashboard, and I should see 14 volts steady. Good. That's a good indication, but it's not enough for me. I'm going to put a clamp meter. What does a clamp meter do? You can see in my videos. Go to see the output, how to measure the output. It measures current. Current to me is a significant way of measuring if the alternator is responding to the computer. I could put a scope and show you the waveforms and pulse width, but I think it'll be too technical. I'm trying to stay very simple, as you see with these type of pictorials now. Trying to stay very simple for the viewers so they understand the concepts much clearer. I put the clamp meter. Let's say it's 20 amps. Let's say your headlamps, they take about 20 amps. Let's say in addition to that, I put the blower motor on or the wipers on, another 10 amps. The computer says Joseph wants the wipers on. Joseph wants the headlamps on. Joseph wants the blower motor on high speed. That's another 30 amps, he tells the alternator. Alternator says, you know what? I will listen to your command, to your request, and I will respond to it. I will give current, the field rotor, to give more current. How do I know that? I put the current meter, as you see in that video. A video is worth 1,000 words. And if that current goes up, I know the computer listened to my request. and I know the computer gave him the command, and I know he listened to that command. That's the most important. That's a simple way of my technique to make sure that the computer is working. There are other ways also, but if you understand that, please leave a comment. If you don't, go to the video how to test the alternator output, and you'll see the clamp meter that I use so much in these videos. Anyway, like I said, I need only 52 hours to get 4,000 hours. Unbelievable. It was before almost 30,000 minutes ago. Now I need about 3,000 minutes, which is 50 hours. Anyway, thanks for the support. We'll see what happens. But anyway, go to my channel, Joe Electronic Schematics for Auto. You'll see those type of videos. The other channel was, which I guess I haven't been doing so much, is Automotive Electronic Schematics for Joseph. Other videos, more for student videos, for basic electronics. But anyway, hope you enjoyed the video. If you found this helpful, please give me a like. It gives me inspiration. Thanks.